Okay, so we're going to continue to solve quadratics. So we've done quadratics with a graph, and then we've done it with factoring. Now, sometimes neither of these will work because of the value being more specific. So on a graph, you can, click on it and see a decimal or whatever, but sometimes your answer choices are not going to be decimals. They are going to include radicals. So what we do here is use the quadratic formula. Good thing is you do not need to have it memorized. It is on your math chart. But I do want you to write it down now so you have access to it. Square root of 81 is 9. Now, obviously 32 is not a perfect square, so we do have to do our prime factors. So I'm going to take a chance here, 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So from here, I'm going to circle my groups, and these two are going to come out. So then it would be 2 times 2, which is 4 times the square root of 2. Notice how this is coming back. This is why we spend time doing all these skills, because in algebra, everything tends to overlap. So we do have to be mindful and ready for using concepts over and over again. Now, 486 is a whole nother beastie. So let me get my prime factors of 486. Factorization of 486. So here are my factors. So it's not too bad. So it'd be 2 times 3 times 3 times 3 times 3 times 3. Circling my groups of 2. Unfortunately, this is all I can take out, so this would be 9 times the square root of 6. Remember, what's left gets multiplied, and what gets taken out gets multiplied. So I just wanted to refresh your memory on how to do this, because it is going to come into play today. So what we're going to do is look for solutions here. What I'm going to use is this equation here. First of all, I need it in standard form. So with x squared minus 8 equals 2x, it is not quite in standard form yet. So I'm going to subtract 2x. So I have x squared minus 2x equals, minus 8 equals 0. So remember, your goal is to get it set to 0. So I'm going to pull all the values here. So a is 1, b is negative 2, c is negative 8. So now I'm going to go ahead and take my quadratic formula and substitute my values. So for b, that would be a negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 8 all over 2 times 1. So it looks like it's crazy, but it's not. Remember, everything is going to kind of come together in a nice, neat package. So I'm going to start here. Negative 2, or opposite of negative 2 would be 2. Plus or minus. Now, under that radical, this is what we call the discriminant. 2 squared is 4. And then we have 4 times 1 times negative 8. So that becomes a positive 32. I can actually erase some of this. I made it a little too long. And then, of course, this is all over 2. So we're getting there. So I'm almost as simplified as I'm going to get. So I have 2 plus or minus. So 32 plus 4 is actually 36, and it is a perfect square. So we would do 2 plus or minus 6 over 2. Now, the plus or minus does come into play. So I am going to do 2 plus 6 over 2, and then 2 minus 6 over 2, because we will have two solutions. So 2 plus 6 is 8 over 2 would be 4. 2 minus 6 is negative 4 over 2 would give us negative 2. So our two solutions are 4 and negative 2. I know it looks like a lot, but sometimes this is going to be our only route. All right, let's try another one. This one is already written in standard form for us, so that's nice. So we have 4, 7, and negative 15 for our values. So when I go to substitute, we would have negative 7 plus or minus the square root of 7 squared minus 4 times negative 15. So you'll notice it works best when you have a negative, one of those values to be negative anyway. All right, I'm almost there. Oh, and then in the denominator, we would have 2 times 4, which is 8. So let's simplify where we can. Negative 7 plus or minus the square root of, this would be 49 minus, we would have 15 times 4, which would be 240. And then, of course, over 8. Oh, it would be plus 240. So, negative 7 plus or minus the square root of 289 over 8. And I'm not sure if 289 is a perfect square, so let's check that. It is. Lucky us. So as I continue to solve this, this would be 7 plus or minus, the square root of 289 is 17 over 8. So I'm going to do this twice. So we would have 7 plus 17 over 8, 7 minus 17 over 8. So when I end up solving this, 7 plus 17, 24 divided by 8 would be 3. So this one would, I'm running out of room here. We'll make this here 3. And then I would have 7 minus 17, which is negative 10 over 8. So in this case, we would leave it negative 10 over 8 or negative 5 over 4. You can probably leave it improper and it would work just fine. All right. Let's continue. I do have to get this one in standard form, so this would actually be 3x squared minus 41x plus 110 equals 0. So when I pull my values, A has a value of 3, B is negative 41, and C is 110, and it's positive. So that may make a difference for us today. So negative B, so this would be negative 41 plus or minus the square root of negative 41 squared minus 4 times 3 times 110. And it's positive. Remember, this isn't the one we're using. All over crazy values. 2 times 3. Okay. Here goes nothing. So 41 plus or minus the square root of 41 squared, 1,681 minus, so we have 110 times 3 times 4 would be 1320 over 6. All right, so 1681 minus 1320 is 361. So we would have 41 plus or minus 361, or the square root of 361 over 6. And let's see if it's a perfect square. It is. So we would have 41 plus or minus, it happens to be 19 over 6. So when I do this twice, we would have 41 plus 19 over 6, and then 41 minus 19 over 6. 41 plus 19 divided by 6 is 10. 41 minus 19 divided by 6 is a crazy decimal. So it looks like, let's see, 41 minus 19 is 22 over 6. But I can simplify by dividing by 2. So it would be 11 over 3. So then our answers are these two values here. Now I am going to talk to you about one more thing. Let's say you're solving, everything's all fine and dandy, and you get here. Let's say you have 3 plus or minus the square root of negative 16 over 2. Making this up. Anytime you have a negative under this radical, you are going to say no solution. So you cannot have the square root of a negative value. There is no such thing. So anytime, so we're going to put negative under radical or under square root would be no solution.